Okay, fine. Starting with the introduction part of motion in a straight line. Okay, so as you know that straight line is nothing but what, which is concerned with the one dimension, right? Okay, so we are concerned in this chapter only about the motion of an object which is moving in a straight line, that is in one dimension. Okay, so next, coming to the introduction part, it is said that we observe different types of objects or bodies around us. Some of them are at rest and some of them are in motion. For instance, houses, stones, rocks, etc. are at rest, while air, flying birds, moving animals, moving cars, etc. are in motion. Okay, so it is said that we observe different types of objects. Okay, some of the objects it is at rest. Okay, and some of the objects which are in motion. Okay, the motion, when you take an example, moving birds, moving cars, these are an example. Okay, coming to this, the bodies which are at rest, or the objects which are at rest, so rocks, stones. Okay, so these are nothing but the example for the body which are at rest. Okay, so hence the branch of physics which deals with the study of motion of material objects is called mechanics. Okay, so the branch of physics which deals with the study of motion of an object, okay, motion of an material object is called, we call that branch of physics as mechanics. Okay, so mechanics can be broadly classified into following branches. The one is statics, the second one is kinematics, the third one is dynamics. Okay, so coming to the first, that is statics. Let us see what do you mean by the statics. It is a branch of mechanics which deals with the study of material objects at rest. Okay, so where we are going to study about the objects which are at rest is called as static. Okay, so the branch of physics which is dealing about the objects which are at rest is called as statics. Okay, so next, coming to this kinematics, it is that branch of mechanics which deals with the study of motion of material objects without taking into account the factors which cause motion. Okay, so for example, I mean, the meaning of this is nothing but, so kinematics is a branch of mechanics, okay, which deals about the study of motion of objects. Okay, but where we are not worried about what is the factor causing the body to be in motion. Okay, we don't worry about that. This one, which is that we don't worry about the cause. Okay, what causes the body to be in motion. Okay, so next, coming to this dynamics, it is that of mechanics which deals with the study of motion of objects taking into account the factors which cause motion. Okay, dynamics is nothing but it is a branch of mechanics. Okay, so where we are going to study about the motion of an object. Okay, considering the uh, considering the factor which causes the motion. Okay, what makes the body to be in motion, we are going to consider that. Okay, so these are nothing but the where the mechanics has been classified in three types: statics, kinematics and dynamics. In statics, we are going to study about the objects which are at rest. Next one, kinematics, is nothing but we are going to study about the body which are at motion. Okay, which is in motion, but we don't worry about the fact that what makes the body to move. Okay, or what makes the body to be in motion. Coming to this dynamics, it is said that, so we are going to consider, okay, what makes the body to be in motion. Okay, so these are the three branches of mechanics. Coming to the next, object in motion. Okay, first in that, rest. An object is said to be rest if it does not change its position with time with respect to its surrounding. Okay, so when do you say that the object to be at rest? Okay, when the object doesn't changes its position with respect to time and with respect to its surrounding, right? We say that the body is to be at rest. Okay. So next, when do you say that the body is in motion? Okay. It is said that an object is said to be in motion if it changes its position with time with respect to its surrounding. Okay. So if the body changes its position with respect to time and with respect to the surrounding, we say that the body is in motion. Okay. So this is how we are going to say that when the body is to be at rest and when the body is in motion. Okay. So next, let us see how this rest and motion are relative. Okay. How this rest and motion are relative. It says that it means an object in one situation can be at rest, but in another situation the same object can be in motion. For example, a person sitting in a moving train is at rest with respect to his fellow passengers, but is in motion with respect to the objects outside the train. Similarly, a person sitting in his house is at rest to the earth, but is in motion with respect to the other planets. Okay. So just we are finding the, we are just seeing how this rest and motion are relative to each other. It is said that some of the objects in one situation can be at rest, but in another situation it will be in motion. Okay, the same object will be in motion. For an example, it is said that when you are traveling in a train, okay, the co-passenger who is sitting next beside who is next sitting beside you, okay, he will be at rest with respect to you, right? So for the person who is standing, okay, or the person who is outside the train, okay, for him you people are in motion. Okay. So hence, like this, the rest and motion are relative. Okay. In one situation it is said to be that the object will be at rest, but in the another situation the same object will be in motion. Okay. So similarly, they have taken an example of earth. Okay, as you know that the earth keeps on revolving, right? So when you take a house, okay, which is at rest, okay, with respect to earth, okay, our house is at rest with respect to earth, but when you view through the other planets, okay, when you compare this with the another planets, the our earth will be in it will be in motion. Okay. So this is regarding the rest and motion, how they are both relative to each other. Okay. So next is nothing but rectilinear or translatory motion. What do you mean by this rectilinear? Okay, first of all, the name itself says linear, something related to straight, right? So it is said that motion in which a particle or a point mass body is moving along a straight line. Okay, the body which is to be moving along a straight line is called as rectilinear motion or translatory motion, we call. Next, coming to this frame of reference. Okay, the frame of reference is a system of coordinates axis attached to an observer having a clock with him with respect to which the observer can describe position, displacement, acceleration, etc. of a moving object. Okay, frame of reference is nothing but it is a system, okay, where an observer has a clock, okay, with him so that he can describe the position, displacement, acceleration of an observer. Okay, so this is called as frame of reference. Okay. So next, coming to this motion in 1 dimension, 2 dimension and 3 dimension. Okay. So when we talk about this motion in 1 dimension, okay, so where we are going to consider only the position of an object which changes with respect to time. Okay. So that is nothing but it is said that the motion of an object is said to be one dimensional motion if only one out of 3 coordinates specifying the position of the object changes with respect to time. So usually we consider 3 coordinates, right? X, y and z. Suppose the motion of an object is only concerned to one of the coordinates out of 3, either it can be x, either it can be y, either it can be z. Okay. So out of 3 where we are going to consider only one coordinate specifying the position of an object with respect to time is called as one dimension. Okay, so next is nothing but they have given an example, the motion of a train along a straight line, I mean along a straight railway track, that is an example. So next, coming to this two dimensional motion, the motion of an object is said to be two-dimensional motion if out of 3 coordinates specifying the position of an object with respect to time. Okay, so where we are going to consider 2 out of 3 coordinates. Okay, we are going to consider 2 coordinates to specify the position of an object with respect to time. Okay, example, you can see an insect crawling over the floor. Okay, that is an example. So next, coming to this three-dimensional motion, so where we are going to consider all the 3 coordinates axes for specifying the position of an object with respect to time. Okay, so the example is nothing but random motion of a gas molecule flying bird. So these are some nothing but the example for one dimensional, two dimensional and three dimensional motion. Okay, so do one thing, just go through from the beginning, starting from introduction about mechanics, types of, I mean branches of mechanics, then how the rest and motion are relative, next frame of reference, next motion in one dimension, two dimension, three dimension. Go through every uh, topic what we discussed right now. So in case if you have any doubts, please let me know. So once you have just gone through about this, we will move to the next topic. Okay, right now go through the topics. Okay, fine. Any doubts, students? Yes, Kushi, Gokul, Mohammed. Okay, fine. No doubts. How about others? Have you gone through? Yes, what man, Ullas? What is the dimension? Okay, fine. Next, coming to this scalars. Okay, so as you know that you have been studied about the scalar quantities and vector quantities, right? So which are the quantities we call that as scalar? The physical quantities which have only magnitude but no direction are called as scalar quantities. Example: mass, length, time, distance, etc. Okay, so similarly, when it comes to vectors, so the physical quantities which have magnitude as well as direction are called vectors. Okay, so so the physical quantities which has both magnitude and direction are called as vectors. Example: displacement, velocity, acceleration, okay, and force. So now next, coming to this distance and displacement. Okay, so let us see what is the difference between this distance and displacement. Okay, so first of all we will move with distance. Okay, the length of the actual path traveled by a particle between initial and final positions of a particle given in a given interval of time is called distance covered by the particle. Okay, so it is said that the distance is defined as the length of the actual path traveled by a particle between initial and final position. Okay, so the distance, I mean the length between the actual path traveled by a particle between initial and final distance or the initial and final positions, okay, in a given interval of time is called as distance. Okay, so to understand this, let us take an example. Okay, as you can see there in the figure, you have a triangle. Okay, so see here in that it is said that let a particle goes from position A to B, then uh, to position C and back to A as shown in figure. Okay, as shown in figure 1 in a time t. So it is said that the particle is moving from starting from A to B, B to C and C to A. Okay, so now you need to calculate what is the distance covered by the particle in a time interval t. So what is the distance from A to B? It has been given in the figure, it is 2. From B to C it is 3. Again from C to A it is 5. So the total distance comes out to be as 10 meter. Okay, so this is regarding how you are going to calculate the distance. Okay, and the SI unit of the distance is nothing but it is meter. Okay, so hence distance traveled by a particle or a body in a given time interval is always positive. Okay, and as you know that the distance traveled by vehicle is measured by a device known as odometer. As you know that uh, in the vehicle. Okay, so how you are going to calculate the distance traveled by the vehicle? You have a odometer, right, which shows what is the kilometer covered. Okay, that itself is known as odometer. Okay, so this is regarding the distance. So coming to this next, displacement. So displacement is nothing but what? The shortest distance from the initial position to the final position of the particle is called displacement. Okay, once again I'll read that definition. The shortest distance from the initial position to the final position of the particle is called displacement. Okay, and to understand this, let us take an example. Okay, as you can see there in the figure, O is the origin. Okay, in the figure 2 you can see there O is the origin and we have 2 points which is situated at A and the second point which is situated at B. Okay, so the distance from O to A is xi. Okay, and the distance from O to B is xf, x subscript f. Okay, x subscript I and x subscript f. Okay, so now you need to calculate the displacement. So just I'll read out that explanation, I mean theory part. Consider a particle moving along x-axis in a straight line as shown in the figure 2. Let its position from a fixed point BO at A, whose distance from O is x subscript I. Let after time t the particle moves to position B such that its distance from O is x subscript f. Then the displacement of the particle in the time interval t is given by delta d is equal to x subscript f minus x subscript I. Okay, so here it is said that first of all, what it is said, we have consider the point O. Okay, and we have the two uh, and we have the 2 points, that is A and B. Okay, where the object, where the particle is moving from O to A. Okay, next what happens, again from A to it moves towards B. Okay, so what is the displacement? Displacement is nothing but it is always final position minus initial position. Okay, so you can see in the figure, just go through the figure 2 and just compare the equation. Okay, so see here, we will just see the figure and compare this equation, delta d is equal to x subscript f minus x subscript I. It is said that the particle is moving along the x-axis from the origin O. Okay, so what happens, the particle moves from O to A. Okay, so again from A to B after certain interval of time. Okay, after a time gap, some time gap. Okay, after a certain interval of time, the particle again moves from A to B. Okay, so now if you want to calculate the displacement of a particle, how you are going to calculate? Displacement is nothing but A minus B. Okay, so the displacement is nothing but it is, sorry, B minus A. Okay, so the displacement comes out to be as you know that after a certain interval of time the particle moves from A to B. So now the initial position is A and the final position is B. So the displacement comes out to be as, delta d is equal to x subscript f minus x subscript I. Okay, so delta d in the figure denotes the displacement of a particle. Okay, so this is how we are going to calculate the displacement. Suppose if I say in the same figure to calculate the distance, how you are going to calculate? You are going to consider O as the origin. Okay, O as the initial position and B as the final position. But here in the case of displacement, as you know that first the particle moves from O to A. After certain interval of time, it starts again from moving from point A to point B. Okay, so now you need to calculate the displacement. So our initial position right now will be A and the final position will be B. So displacement comes out to be final minus initial position. Okay, so this is how we are going to calculate displacement, and this is what is the difference between distance and displacement. Okay, so now it is said that displacement is a vector quantity which has both magnitude and direction. Okay, so as you know that the displacement is, it is a vector quantity which has both magnitude and direction. So it is said that the displacement can be positive or negative or 0. Okay, so the displacement can be positive, negative or 0. Okay, let us see an example for when is the displacement is positive and when is the displacement is negative and when is the displacement is 0. So in the figure 3a, it shows it is regarding the positive displacement. Okay, so let us go through the explanation part. It is said that when an object moves to the left in a time t1 to t2, its displacement is positive. Okay, so see, it is said that, let us say that when the object is moving from left to right. Okay, so in a time interval from t1 to t2. Okay, so if that is the case, so what happens, how we are going to calculate the displacement? Okay, right now let us consider the object is at O. Okay, and it has reached the point B. So now you need to calculate the displacement. So if you consider, okay, if you consider, I mean, if you want to calculate the displacement, so as you know that how you are going to calculate the displacement, it is always x2 minus x1. Okay, it is x2 minus x1. If you do, as you know that it will be greater. Okay, and this type of displacement is called as positive displacement. Okay, so similarly coming to this next one, that is negative displacement. As you can see in the figure here, when an object moves to the left in time t1 to t2, okay, its displacement is negative. Okay, so let us see how is that. When an object remains in the figure 3, you can see here the object is moving from A to B. Okay, the object is moving from starting from point A to towards the left side. Okay, when you take a x2 minus x1, it will be always lesser than 0. Okay, when x2 is nothing but what, it is the final position, and x1 is nothing but the initial position. When you subtract the final minus initial position, if the value is less than 0, it is said to be negative, right? So hence this type of displacement is called as negative displacement. Next, in the third figure 3c, you can see there, when an object remains stationary or it moves first towards the right and then an equal distance towards the left, its displacement is 0. As you know that, let us say that the object is at O now, as of now. Okay, so now it moves towards the right side, that is at point A. Let us say that the displacement is x1. Next, again what it does is it again moves, come back to its initial position at O itself. Okay, so again consider the displacement as x2. So when you subtract this x2 minus x1, you are going to get the displacement as 0. So hence this is an example for a 0 displacement. Okay, so this is regarding the distance and displacement. Okay, first just go through about distance, next go through about displacement, next just compare yourself what is the difference between this distance and displacement, and then next go through about this when is the displacement is negative, when it is positive, and when it is 0. Just go through for a few minutes. So in case if you have any doubts later, you can ask. Okay, fine students, any doubts? Yes, any doubts regarding today's topic? Okay, fine. So see, in case if anyone has a doubt regarding this positive displacement and negative displacement, okay, let me make it very simple. So see, if you take a scale, if you consider this as a scale, so this will be the 0, right? So let us consider this as 25 centimeter and this is 50 centimeter. Okay, let us say that the body is moving or the object is moving towards the right. Okay, so this will be 0 will be your initial position. Let us say that after certain interval of time the body comes at 50 centimeter, okay, at this position. So if you want to calculate the displacement, so always final minus initial. So final displacement is how much? 50, initial is 0, so 50 minus 0 is equal to 50. So since this number is positive, we say that, okay, it is a positive displacement, we say. Again the same thing, if you consider for a negative displacement, let us say that the objects as of now is at 50 centimeter, okay, it is moving towards the left, so it comes at 0 position, okay, it comes at 0. So if you want to calculate the displacement, how you are going to calculate, which is your final position 50, I mean 0, initial position is 50, so 0 minus 50 is how much? So it comes out to be negative, right? So hence this is an example for negative displacement. Similarly, if you take a body is moving from 0 to 50, again from 50 to 0, this is an example for 0 displacement, okay. So this is regarding the positive displacement, negative displacement and 0 displacement, okay. So this is regarding the displacement, okay. So coming to the today's assignment, okay, do one thing, just write the definition of kinematics, okay, just write the definition of kinematics. Next write down the uh, definition of displacement and distance, okay, write down the definition of distance and displacement with an example, okay. So this will be your assignment. In the next class, please just go through, I mean just I am going to forward these notes in the group, just go through the difference between this distance and displacement, okay, we will discuss that in the next class, okay. So today's assignment is definition of kinematics, next what is displacement and distance, definition of both, okay. So this will be your assignment. So with this thing I will just conclude today's class. The rest of the things we will discuss in the next class, okay. Okay students, thank you.